This video is meant to be the pre-lab and the post-lab for the lab called flame tests. Just as a fingerprint is unique to each person, the color of light emitted by an element heated in a flame is also unique to each element. In this experiment, the characteristic color of light emitted by calcium, copper, lithium, potassium, sodium, and strontium ions will be observed. The purpose of this experiment is to observe the characteristic flame test colors of different metal compounds and to use this information to identify an unknown metal ion. The pre-lab questions, typically I don't ask you to do the pre-lab questions, but I would like you to write down verbatim questions 1 and 2 and then answer them. This will be part of your pre-lab. Next in your pre-lab, you should include the data table as shown here. It's a very simple data table. It has metal ions in the left column and the color of the flame in the right column. You will not need to record the results table. We will not be using the results table for this lab. To perform this lab, you're going to need to know how to use the Bunsen burner. The Bunsen burners can be found in the cabinet that is in the lab bench. Find a Bunsen burner, and your first job is to make sure that the hose is securely fastened to the gas jet as shown here in this picture. To light the Bunsen burner, you will ignite a lighter, and you will hold the lighter very close to the mouth of the Bunsen burner, like so. Once you have the lighter in that position, then and only then will you turn the gas jet on. You'll turn the gas jet on by taking the silver handle and bringing it forward so that it is close to the actual gas jet right here. So full on would be when the handle is directly over the gas jet itself. Full off is when this handle is pushed back either in this direction or pushed back all the way in the right hand direction. But you'll turn the handle so that it is close to the gas jet, and at that point the flame should ignite. It should look something like this. You should see an inner blue cone and then an outer blue flame like so. Down here, this is a handle that you should not need to touch. That's it's meant to adjust the amount of gas flowing in, but that's usually not something that you'll have to touch. You may need to change the amount of air intake, and that would be this part of the Bunsen burner. You can see here that this is how you just turn it around the barrel of the Bunsen burner, and that adjusts how much air is in it. Now, to get that nice flame that you just saw, it takes a fair amount of oxygen to do that, so you can see here that this is wide open, so oxygen is able to come in and mix with the gas coming in the jet. The air-gas mixture goes up the barrel of the Bunsen burner where it then ignites at the top. Once you have your Bunsen burner comfortably lit and it's burning safely, you'll notice that there are 6 different containers on your lab bench. One is labeled potassium chloride, lithium chloride, sodium chloride, copper 2 chloride, strontium chloride, and calcium chloride. The reason they are all chlorides is because what we are interested in testing is the metal, the potassium ion, the lithium ion, the sodium ion, the copper ion, the strontium ion, and the calcium ion. We want to see what color those ions burn when they're in the Bunsen burner. And if they all have chloride, then we know that any color we see is not from the chloride, it's from the metal itself. You'll find some wooden splints soaking in some distilled water. You will need 7 of these. You'll use 1 for each of the substances that you are going to test. You only need a small amount of the substance on the tip of the soaked wooden splint. Okay, this that you see here, this is the copper 2 ion. This is plenty. You don't need any more than this. In fact, this is probably way more than you need. That one's pretty easily visible because it's bluish green. Here's one of the other substances. You just need a crystal or 2, just a tiny amount on the surface of the wet splint is plenty. You'll put the soaked wooden splint into the flame, and you'll notice that it produces a color that's different from the blue flame. This is the color of the flame that you're going to be recording into your data table. Each of those 6 substances will burn a different color, and that's what you need to take note of. You'll find that there's one of 2 unknowns. You either have unknown A or unknown B. This will be the 7th chemical that you'll burn, and that's what your job is, to identify that unknown based on the color that it burns compared to the other 6 that are known. When you are done using a splint, there should be a beaker at your desk called rinse water. This is where you extinguish any burning splints, and you leave those splints to soak. You do not reuse those. Okay, once they have a chemical on them, they're contaminated, and it really never comes off. So just leave the used sticks in the rinse water, and at the end of the lab you can dispose of the sticks. Gas, of course, needs to be turned off all the way. Make sure you push that handle back all the way until you feel it stop. Either direction, to the left or to the right, will work. Just make sure that you push the handle all the way until it stops. There's 2 post-lab questions I'd like you to do after the lab is done. Numbers 5 and 6. Please answer these questions in complete sentences. To finish up this lab, you'll need to write a summary of procedures. Describe what you did with the metal chloride crystals and the Bunsen burners. Tell me what you did at the lab bench. This is not the place to tell me what color they burned or what your unknown substance is. That's what you're going to say in your conclusion. Your conclusion, tell me what flame color specifically did you observe with each metal. So tell me the potassium ion produced which color, the lithium ion produced which color. Okay, using complete sentences, don't give me a list. And then you need to tell me what your unknown crystal is, what you think it is, based on the color that it burned. Improvements are not necessary for this. This concludes the pre-lab and post-lab video for flame tests.